Electronic chips have become a vital item in today's society. From artificial intelligence, big data, 5G, satellites, high-tech industry, military, industrial production to people's daily life, it is almost everywhere. Cell phones, internet, computers, shopping payments, bank settlements, and even car control all rely on chips. Without it, people's life and the entire social system would immediately fall into chaos. So the comparison of the chip to the core of modern industry power is not exaggerated. The United States semiconductor company Intel announced on March 23rd that they will invest $2 billion to build 2 more chip plants in Arizona and will establish the Intel Foundry Services, a new standalone business unit to expand the company's IC foundry services. Intel's strategy is interpreted by experts as a direct challenge to Taiwan's TSMC and South Korea's Samsung. And the more practical significance of this plan is to reduce the U.S. dependence on chip imports. The background of Intel's announcement of this major strategic adjustment is thought-provoking. Since the trade war, the conflict between the United States and China has gradually escalated. On the surface, the confrontation between the United States and China has intensified in many areas such as commerce, diplomacy, and military. But essentially, the technological competition between the United States and China is more critical, and chips are the top priority. On March 17th, Chinese chip foundry SMIC announced an investment of $2.35 billion to build a new wafer factory in Shenzhen. And on March 18th and 19th, talks between senior U.S. and Chinese officials in Alaska came to an unhappy end. On March 18th, U.S. Senator Marco Rubio and Representative Michael McCaul urged U.S. Secretary of Commerce Gina Raimondo to apply the Foreign-Produced Direct Product Rule to the SMIC entity listing. The two lawmakers want the Biden administration to persuade the Dutch government to prevent the Dutch company ASML Holdings from selling deep ultraviolet lithography machine to SMIC and to set the threshold for chips sold to SMIC at 16 nanometers. In their letter to Raimondo, Rubio and McCaul wrote, because of its designation as a Chinese Communist Party military company and integration into the defense establishment of the PRC and its national strategy for military-civil fusion, SMIC is a clear threat to the United States national security. It is in the U.S. national security interest to prohibit the transfer of goods that might support SMIC's production of semiconductors due to the company's role in helping the CCP military's pursuit of displacing the United States to achieve global preeminence in the future. Deep ultraviolet lithography, or DUV, is an important tool for the mass production of high-level chips for artificial intelligence and military development, and poses a threat to U.S. national security and foreign policy interests. The sanctions against SMIC, which can be considered an escalation of the U.S.-China technology dispute, are a major move following the United States sanctions against Chinese technology companies such as Huawei and ZTE. The sanctions against SMIC are far more significant than those against terminal product manufacturers such as Huawei. This is because chips are vital to the industry as the entire industrial system depends on it. In response to the potential economic and geopolitical impact of the current global chip shortage, U.S. President Joe Biden ordered a 100-day industrial supply chain review in late February. The United States must now address how it can expand chip production capacity globally and within the United States. Biden has begun to link Taiwan, Japan, and South Korea and other partners to establish a less dependent on China supply chain. But the United States is also worried that over-reliance on Taiwan could become a weakness. If mainland China annexes Taiwan by force, it will acquire TSMC's R&D and manufacturing base, which is equivalent to a direct defeat for the United States. If China does not attack Taiwan, the United States would need to import nearly 90% of its integrated circuits from East Asia, exposing the weakness of total dependence on foreign production of semiconductors. As a result, the United States encouraged TSMC to set up factories in the United States to revitalize the U.S. semiconductor industry. Intel's expansion of its wafer factory is also a way to reduce its dependence on foreign chip supply chains. The Chinese government's efforts to support the expansion of SMIC's wafer factory can be considered one of the responses to the chip shortage. Its goal is also to control chip production capacity and technology, reducing dependence on imports while trying to break the sanctions. Intel's new 7nm chips will use the extreme ultraviolet lithography tools. Relying on Intel's technology and experience accumulated over the years, its success probability may be relatively large. What about China's SMIC expansion? Can SMIC solve the problem of lack of chips in China's manufacturing industry? SMIC, China's largest chip maker and the fifth largest in the global market, was blacklisted for export by the Trump administration last December. The first four major shareholders of SMIC hold 62.53% of the shares, all of which are Chinese state-owned enterprises, including two enterprises directly under the central government, one enterprise under the China Foreign Exchange Administration, and one enterprise under the China Integrated Circuit Investment Industry Fund. This shows that the actual controller of SMIC is the Chinese government. On the evening of March 3rd, SMIC made an announcement that it had signed a purchase agreement with global lithography giant ASML from the Netherlands to extend the purchase agreement until the end of 2021. With the total order price exceeding $1.2 billion United States dollars. ASML had recently confirmed the continuation of the sale of DUV lithography to SMIC until the end of 2021. Behind the agreement between SMIC and ASML to purchase lithography machines is the plan of the Chinese Communist government. On February 26th, the Wuhan Hongqin chip project, which was heavily supported by the Chinese government with a total investment of $15 billion USD, was officially declared bankrupt, making the failure of China's Great Leap Forward chip campaign. The video we released on March 15th about HMMC and the Great Chip Leap Forward is a special introduction for our viewers. After the failure of the Wuhan Hongqin project, the only Chinese chip manufacturer that the Chinese government can rely on is SMIC. On the evening of March 17th, SMIC made an announcement that it will jointly build a wafer project with the Shenzhen government to mainly produce integrated circuits of 28 nanometers and above, and provide technical services aiming to achieve an eventual capacity of about 40,000 12-inch wafers per month. The total investment for the project is approximately $2.35 billion United States dollars. SMIC and the Shenzhen municipal government own approximately 55% and no more than 23% of the equity, respectively. Production is expected to begin in 2022. Why did SMIC conservatively choose 28 nanometer chips and above? There are three main reasons. First is the equipment issue. SMIC is blacklisted because of the support provided by the CCP military and can only obtain DUV lithography, which uses a light source of 193 nanometer wavelength ARF excimer laser and can achieve the 28 nanometer and above process with one exposure and 7 nanometer process with multiple exposures. But the problem with multiple exposures is the high cost of production and low product yield, mainly due to the resolution of the light source and for the lithography. SMIC's 14 nanometer chips entered small-scale mass production in the fourth quarter of 2019. For the fourth quarter of 2019 and the first quarter of 2020, 14 nanometer process revenue accounted for 1% and 1.3% of total revenue respectively. SMIC has listed the 14 and 28 nanometer processes together in its investment since Q2 2020, so it is not yet possible to determine the specific revenue share of the 14 nanometer process. Q3 2020 data released by SMIC shows that 14 nanometer and 28 nanometer revenue together accounted for 14.6% of total revenue, of which the percentage of 14 nanometer revenue is unknown. A process called EUV lithography is needed to produce 7 nanometer and more advanced process chips, which currently only ASML companies produce. The EUV lithography tool is matched with a 13.3 nanometer laser pulse tin plasma light source, which can achieve a 7 nanometer process with one exposure. SMIC once signed a contract with ASML to order an EUV but was unable to deliver due to technical sanctions. The EUV is an essential piece of equipment if they are to produce chips for 5 nanometer and higher processes. The second reason is the problem of photolithography. TSMC, Samsung, and other major manufacturers have accumulated many years of experience. These chip factories use a more advanced 5 nanometer process, which is a superior process because more transistors can fit in the same size chip, boosting power and efficiency. SMIC is a company established only in 2000, and despite the introduction of multiple semiconductor industry luminaries, the actual production process is still in the need of R&D. The development of semiconductor technology is not only dependent on advanced equipment. Each generation of lithography process is to be iteratively applied to the next generation of products, such as using a 14 nanometer technology to develop 10 nanometer technology. Companies with strong technical strength may be able to skip a generation of technology nodes to do research and development, but it's impossible to skip 2 generations of technology nodes. So even if SMIC has an EUV lithography, it cannot achieve 7nm and more advanced process chip mass production in the short term. TSMC used EUV lithography to achieve 7nm mass production, while SMIC could not. SMIC ordered EUV at the time mainly to develop more advanced process technology, not to produce chips. The third reason is the market problem. SMIC's 2020 third quarter report shows that nearly 70% of its sales revenue comes from mainland China and Hong Kong. The largest share of its foundry revenue is from the 0.15 and 0.18 micron chips, accounting for more than 31% of total revenue. This is followed by the 55 and 65 nanometer chips, accounting for about 26% of its revenue. The 14 and 28 nanometer accounts for 14.6% of total revenue, of which 14 nanometer accounts for an unknown amount. SMIC's largest customer is Huawei's HiSilicon, which contributes to 17 to 25% to SMIC's revenue. SMIC's second largest customer is Qualcomm, which contributes 13 to 21% of SMIC's revenue. SMIC manufactures 28 to 14 nanometer chips for low-end mobile phones and 0.18 micron power management chips, and 40 to 65 nanometers for internet application processors for other customers. This shows that SMIC's main products serve the low-end chip market. So the question becomes, can SMIC's expansion save Huawei from its predicament? If Huawei is still committed to manufacturing high-end cell phones, the answer is no. If Huawei transforms into the direction of mining digital applications or other lower-end market, the answer is yes. High-end cell phones need 7nm chips and more advanced manufacturing processes. After Huawei was sanctioned, TSMC, Samsung, and other manufacturers can no longer export high-end cell phone chips to Huawei, and SMIC cannot build high-end cell phone chips. So Huawei withdrawing from the ranks of high-end cell phone manufacturers is inevitable. China's chip market was $143.4 billion in 2020, up 9% year-on-year, making it the world's largest chip market. In 2020, local chip makers in China produced a total of only $8.3 billion worth of chips, accounting for only 5.9% of the Chinese market's own demand and only 2.1% of the global market share. In 2020, SMIC's total operating revenue was $4.16 billion. Its production capacity is still far short of China's chip import demand. China's response to the current situation is mainly reflected in the 14th Five-Year Plan, a draft plan that includes broad goals for Chinese economic and social development over the next 5-year period. Unlike the 5-year plans of previous years, this year's draft 14th Five-Year Plan also includes China's vision for 2035. Beijing hopes to achieve major breakthroughs in core technologies and enter the forefront of innovative countries in the next 5 to 10 years. The Chinese government has proposed to increase research and development investment by 7% each year. It also stipulates that the added value of emerging industries should reach a target of more than 17% of GDP during the 14th Five-Year Plan. In terms of chips, Beijing hoped to achieve 70% domestic production of chips used in the country by 2025. Due to the Chinese government's policy support of funding and the taxation, tens of thousands of chip-related enterprises have been established in mainland China in recent years. Many enterprises and individuals from cement, construction, catering, and other industries have switched to the chip sector, opening up the era of China's great leap forward in chips. Many scams have been created as a result. However, chip design and manufacturing cannot just be copied. The chip industry is mainly divided into 5 areas: equipment, integrated circuit design, chip materials, chip manufacturing, and chip packaging and testing. Foreign technology, especially US technology and equipment, is indispensable to almost all parts of China's chip production chain. For example, chip design requires the use of United States company Synopsys and Cadence's EDA design software. If the United States joins its allies to restrict China's import of advanced chip design, manufacturing, and other key technologies and equipment, China's chip technology development will be greatly restricted, and China's chips will continue to rely heavily on imports. The CCP's dream of manufacturing power and Made in China 2025 will also be broken. Even if the Chinese government vigorously supports SMIC, the current strength of SMIC alone cannot change the pattern of China's long-term dependence on chip imports.